Hello, everyone, and welcome back to Learning SAS with Jelly. Today, we are on lesson 18, which is T-Test. So, I'm starting a whole statistics playlist. So, for those who are interested in statistical analysis and eventually things like machine learning, data analysis, all of those have a statistics foundation. So, the first video was PROC univariate, and now we're going to go into the T-Test, which is a common hypothesis test. Okay. So, first and foremost, what actually is this t-test? So, I already told you that it's a statistical test and it compares the means of two groups. Okay. If you have more than two groups, you're going to use something called ANOVA, which I'm going to have a video on next. But two groups. So, for instance, you're trying to compare if the mean weight of people who received the medication is different than the mean weight of people who received a placebo. You're trying to figure out if the mean sales in one store is different than the mean sales in another store. So you're comparing two groups' means together. In any standard t-test, it's a hypothesis test. So you have to have a question or a business problem. And the standard null hypothesis is that the true difference between these groups is zero. Okay. So the mean between these two groups is zero, or alternatively, that the true difference between these groups is different than zero. Okay. So, one, you can basically say that the mean of the two groups are equal. The alternative is that the mean of these two groups are not equal. All right. So, when do we actually use this test? So, as I mentioned, it's when you want to compare the means of two groups. We have some lovely use cases here that we can talk about. So, say for instance, you want to see if a sample of a vehicle's city's miles per gallon is different than the population mean. That's going to be what we call a one sample t-test, which we're going to talk about in our next slide. If the mean sales of my product in December is different than the mean sales of my product in January, is the mean blood pressure of patients who didn't take the drug different than those who did? And is the mean score on a pre-test for students different than the mean score on a post-test? So there's tons of different business cases, use cases, and questions that t-test can help you answer even before you get to more sophisticated testing, right? So you want to start simple and then build your way up to complex. And a lot of our business problems and use cases can be solved with something like a t-test or a form of hypothesis testing. Okay, so what are the types of t-tests that you need to be aware of? Okay, so three main types, as you can see on the screen below. So the first type is the one sample t-test. Okay, and that's what I had an example in the previous slide. So is there a difference between a group and the entire population? So the example that I gave before, is there a difference in this sample's mean car performance than the entire population of cars that you're pulling from? Okay. So you're taking a sample and you're comparing it to the population. And with that, most of the time, the population mean and variance or standard deviation is known. Okay. And a lot of times that is not known. So this is one of the most uncommon tests that I have personally used, but there are use cases for it. One of the biggest, most common tests that I've used in data science, data analytics is something called a two sample independent t-test or an unpaired sample t-test. And you are looking for the difference between two groups. So is the different weight for this one group, is it significantly different than another group? Is the sales in January significantly different than the sales in December? Things of that nature. So I have two samples and I'm comparing those samples together. And then there's also something called a paired t-test, okay? And most of the time it's the difference in a group between 2 points in time. So this could be the blood pressure before you receive treatment compared to the blood pressure after you receive treatment. So a lot of these with a paired sample test is a before and after, or a pre and a post, okay? But hands down, the most common one that I have used is an unpaired sample test or two independent sample t-tests, where I'm comparing two samples together. Okay, so let's walk through each one of these one by one and get like a little scenario so we know exactly what each test is for. So that one sample t-test where we have a sample and we're comparing it to the population is to test whether an unknown population mean is different from a specified value using one sample. Okay, so in this case here, Miss Lucy was told that the average test one score for students in computer science 1 is 83. She does a random sample and chooses 33 students from all of the computer science 1 courses to test the hypothesis and gets their average score to be 88. Is this significantly different? So, the population in question would be all the students who take computer science 1, okay? And she wants to compare whether her sample of 33 students average, which is 88, is different than all of the students' average, which is 83. Okay. So she took one sample from the population and compared that sample to that population. Hence, this is what we call a one sample t-test. So, do you have the population in question's average and their standard deviation or variance? And do you want to compare one sample to that overall population? The next type is the two independent sample t-test or unpaired t-test, and it's to test whether the unknown population means of two groups are equal or not. So basically, you're comparing two groups together. And so we have an example here that we can walk through. Dr. Doe was told that a new drug would significantly decrease a patient's systolic blood pressure. Dr. Doe recorded the blood pressure of a group of 48 patients who did not take the drug and got a mean of 148. She also recorded the blood pressure of a group of 51 patients who did take the drug and got a mean of 155. Are these two groups mean systolic blood pressure different from one another? Okay. So Dr. Doe wants to know, for those who had the placebo, this is what their blood pressure is. Those who took a drug, this is what their mean blood pressure is. Are these two groups different from one another? So I'm comparing two samples to each other. Okay. So our next and final t-test is going to be the paired t-test, which we call dependent samples, okay? This is the before and after, or pre or post. So you're testing whether or not the difference between pairs of measures is 0. It's common when you have before or after measurements for a group of people, or that you have a paired difference. So the weight measurements are taken for each person before they start a weight loss program and after. We want to know if the mean weight change after the program is completed is 0 or not. Okay, so I'm going to get that one person and compare that person to itself. Okay, this is why we do the dependent, his or herself, better yet. Okay, so now since we have some knowledge of the different types of tests, we have the one sample test, so a sample versus the population. We have an unpaired sample test, or two independent sample tests, and there's a difference between the groups. That's what we're trying to test. And we have a paired sample test, okay, where we are trying to compare a person to itself or a group to itself at different points in time. So now let's dive in more into this test, and just some background that you should know before you do a t-test is the assumptions. So we're going to talk a little bit about model assumptions when we get into our machine learning models, but statistical tests also have assumptions as well. And so this test assumes that the value in question is continuous or ordinal. So things like weight, height, miles per gallon, scores, things like that. It needs to be a continuous variable that's in question. The sample that you take is representative and randomly sampled from the population. So, did you sample all loyalty customers, right? That might not be representative of the population. Did you sample just one breed of dog? That might not be representative of the population in question. The data itself is normally distributed, and we have a distribution here, and you can read more about this normal distribution. There's a reasonably large sample size. So this cutoff varies across white papers. Some people say if you have more than 30, we're going to stick with 30, that's a reasonable, large enough sample size for you to perform a t-test. And the rationale behind this is as your sample size increases, your data looks more and more normal. Okay? And that equal variance when the standard deviations are approximately equal. Okay, so there's a few assumptions that you need to check for. This is not going to go through how to check for those, but there are a lot of documentation online where you can perform some of these checks. Data is normally distributed. We're going to look at through a QQ plot as well as a histogram momentarily. And of course, sample size, you can count up how big your sample is or not, and you already know if you're using a continuous numeric variable. So these are pretty easy assumptions to account for. Okay, so on top of these assumptions, there's something called a p-value. Okay, and a p-value is just probability. That's what it means, probability. How likely it is that your data could occur under the null hypothesis. Okay, so a small p-value means that it's less likely to occur, and that can lead you to rejecting the null hypothesis. Okay, so if you want a real textbook interviewee type of definition, okay, the p-value tells you how often you would expect to see a test statistic as extreme or more extreme than the one calculated by your statistical test if the null hypothesis was true. Okay. And in so many words, is how likely it is that your data could occur under the null. So if you have a small p-value, that's very unlikely that the null would actually be true, or that what you found is going to mirror the null. Okay. So the p-value, definitely research it, definitely know what the definition is. I've seen this time and time again in interviews, and it's something that you have to use in hypothesis testing. Okay. So along with the p-value, we have something called an alpha level, and it's a significance level, and you determine this level. Okay. And so a good starting point is an alpha level of 5% or 0.05. And we're going to say if the p-value is greater than or equal to 5%, we are going to fail to reject the null. Now, we don't say accept the null. Don't say accept the null. It's a statistician thing, okay? People do not use that wording. You have to say fail to reject the null. So if my probability is greater than or equal to 5%, I'm going to fail to reject the null. That means that there is no difference in the means between the groups. If my p-value is less than 5%, I'm going to reject the null. That means that I find that there is a difference between the group's means. Okay. And like I said, this level is definitely dependent on you. It can be 5%, it can be 1%. It all depends on the business problem as well. Here we have a list of options in Python. I mean, not Python, I'm sorry. A list of options in SAS where you can specify the alpha level. You can specify the null value if needed. You can also request to display confidence intervals. So all of these things are options that you can add to your t-test procedure that I highly recommend that you look up as well. Okay, so now since we have some terminology down pat and we know our assumptions, we want something that's normally distributed. We want something that has a sample size of at least 30 or more. That's what we're going to use. We know that the p-value is a probability of outcome, and we have our alpha level of 0.05. Okay, now we can actually run some code and run a t-test in SAS. Okay, so I'm going to do a 2 independent sample t-test. And as I've mentioned, since this is a hypothesis test, you need a question. Okay, so each group worked out 4 times a week for 90 days. After 90 days, the trainer measured the body fat percentages of both the male and female groups. The trainer would like to know if the mean body fat in males is different than those of females. So I have 2 groups, male and female. I have my numeric variable of body fat percentage. The null here is that the mean male body fat percentage is equal to the mean female body fat percentage, right? And if I get a p-value that's greater than or equal to 5%, I'm going to fail to reject the null, meaning that both male and females mean body fats are equal. Alternatively, the mean male body fat percentage does not equal the mean female body fat percentage. And that's going to be if I have a p-value less than 5%. So I have a question, right? And based off of this business problem in this scenario, I have my null and alternative hypothesis. That's what you have to determine first. Then I can run my code, okay? So I have some example code here, and I'm going to copy and paste this data step for those to run it in SAS Studio as well. But let's go ahead and go to SAS Studio and let's look at our first example. So I'm creating a data set called body fat. I'm inputting 2 variables, the group, which is a character variable, and the body fat percentage, which is my numeric variable. The double at just means that I have multiple observations on one line. So here I have 2 male body fat percentages on the same line. Okay. And then I'm reading in data lines and I have my raw data. Okay. I just made this up. You definitely can make up your own data set as well. And then after that, I have a PROC t-test, okay? So let's run this data set first and look at the output. And we see that we have 32 observations, okay? And we have the group that they're in, and we have the body fat percentage. And we know that this mirrors our data set because the first 2 values was 16.2 and 17.4. So if I click back to code, I have 16.2 and 17.4. Awesome. So I have my data in. You definitely can import a data file. I have some lessons about that if you want to go back a little further in lesson 1 and lesson 2. And then we do a PROC t-test. So the PROC t-test, my data set, which is body fat. The class is group. So that is the 2 groups that I want to compare. In this case, male and female. And the numeric continuous variable that I want to have is the body fat percentage. So I'm going to highlight this and run it. And I get my results out, okay, with some lovely plots as well, okay? So I have my groups. I have the number within each group. I have some summary statistics about the mean, body fat percentages, the standard deviation, min and max. I also have some confidence levels and intervals, and I also have the test statistics. So this is the output here. So I can have a equal variance or an unequal variance, okay? Let's assume that these are equal variance, even though it does not change the t-test statistic in this case. And I see that my probability is less than 0.001, which is clearly smaller than 5%. Now, as we mentioned in our PowerPoint, right, if it is smaller than 5%, then that means that the 2 groups have unequal means, that they're different than each other, okay? So in this case, I'm going to conclude that I'm going to reject the null, which means that both the male and female's mean body fat percentage is in fact different than one another. I can also have normal distribution plots that will show up, as well as QQ plots. The closer your dots are around this line means that it's more normal, okay? So these are things that I can do to check for normality. I definitely can add in more data lines to see how that would affect it. But all in all, I get my p-value. I can compare my p-value to my alpha level. Since my probability is less than 5%, this means that this is less likely to occur. and that both of these two groups' mean body fat percentages are in fact different than one another. Okay, if you don't want to type in data lines, that's perfectly fine. SAS has a lot of SAS help libraries that you can utilize if you expand libraries and expand SAS help. Okay. And so we are going to use the baseball set. So if I double click on the baseball set, I see that there's a lot of information in here, but I do know that the league here, there's only two groups. Keep in mind, T-tests are for two groups. Okay. So I want to compare the home runs by the American and National League to see if they're different from one another. Okay. The mean amount. So in this case, I'm taking in sashelp.baseball. The group that I want to use is the league variable in this data set. And the variable that I'm interested in is the home runs. So I'm going to run this. And notice that I get a similar output. I have the American and national team with some good summary statistics at the top that's similar to PROC means. And down here, I have my T statistic, okay? And I see that my p-value is greater than my 0.05. So keep in mind that if it's greater than, I failed to reject the null. So that means that the American and national home run, the mean amount of home runs that they have in this data set, are equal. Okay. I can look at the distribution. I can also look at the QQ plot. Notice that it looks like this plot breaks for normality, which is an assumption that we have to have for t-tests. So this in itself may not be a proper test to run, but either way, you can get that information from this. Okay. And that is the code. Anybody can run this last line as long as you have SAS Studio On Demand for Academics. And if you do not know how to sign up for SAS Studio On Demand for Academics, I'm going to have a link to the first video below. All right, so in summary, we were able to get our body fat percentages across two groups. We saw that our p-value was less than 5%. So in that case, we reject the null. So there is a difference in mean body fat percentage between males and females. So the mean male body fat percentage does not equal the mean female body fat percentage. In our second example, the question at hand was, is there a difference in the mean amount of home runs hit by the American League versus the National League? So the null here is that the mean American League home runs equals the mean National League home runs. And the alternative is that they're not equal. We end up running a t-test and we got a p-value that was greater than 5%. So in conclusion, there is no difference in the mean home runs hit by the American League compared to the National League, and that is described here in blue. Okay? So once again, t-tests, a very popular hypothesis test that people use in statistics, data analytics, data science, etc. It is a hypothesis test where you're comparing the means of two groups. If you need more than two groups, we're going to do ANOVA in the next video. There are three main types of t-tests: a one sample t-test, two sample t-tests or unpaired sample t-tests, and a paired sample t-test. There are some assumptions that you have to make sure that it's intact before you utilize t-tests. And running t-tests in SAS is pretty much 3, 4, 5 lines of code. You definitely have options within the documentation that you can also add as well. So thank you all for tuning in to Learning SAS with Jelly. I hope you enjoyed this video. Please like, comment, and subscribe, and I will see you on our next video. Thank you. Bye-bye.